Hello students, today we are going to start a new chapter, but this time I am here with a new chapter for class 9. The chapter name is motion. Now, what is motion? First we have to understand this. In your day-to-day life, you might have seen many things which don't change their position. They remain in the same place. Now this position is called the position of rest. That means with time it does not change its position. But you will see many things which keeps on moving, they change their places. We will see that birds are flying in the sky, or a boy is running, or many other examples are there where an object is changing its position with time. This state is known as state of motion. Now, while a thing is in motion, we need something relative to which we will say that the thing is moving or not. That means there should be one reference point. Reference point. Now, what is this reference point? What does this mean? Suppose you are sitting in a bus and you are heading towards your school. Now, in that bus stop, there was a tree, or there is a tree. As soon as you have started, the bus has started, the position of the bus will change with time with respect to that tree. So in comparison with the tree, if I measure the distance of the bus, gradually as the bus will move, the distance will increase, it will change. Now this is called reference point. That means a point with respect to which an object will be considered whether it is in motion or in the position of rest. Suppose here we have taken a point A. Now there is one vehicle which is moving towards this direction. Now at time t1, suppose the bus was here. After some time the bus can be seen at this position at time t2, where t2 is greater than t1. That means suppose in the first 2 minutes I can see the bus at this position. In the next 2 minutes, that means 4 minutes, when the time is 4, that time I can see the bus in this position. So I can say that with respect to this position A, the bus is changing its place. Before the distance between these two were less, and afterwards it has increases. So we can say that the thing is in motion. For example, to make it more clear, you are sitting in the bus, school bus, with your friend. Now both you and your friend, you are going to the school. Now the bus is changing its place with respect to the tree. So we will say that the bus is in motion. But you and your friend, with respect to your friend, you are sitting in the same place. You are not changing your position with respect to your friend. So you are not in motion with respect to your friend, but you are in motion with respect to that tree which was in your bus stop. So I hope it is clear what is reference point and what is motion and what is rest. Now the next topic that we will see, that is scalar quantity and vector quantity. What is scalar quantity and what is vector quantity? You will get this in physics often now and then. So scalar quantity. What is scalar quantity? First you should know what are physical quantities. Things which you can measure, which have some value, magnitude, we call them physical quantities. Now physical quantities can be classified into two. One is scalar, another one is vector. So physical quantities can be classified into two, scalar and vectors. First we will discuss scalar, then we will discuss vector. What is scalar quantity? There are many physical quantities which have only magnitudes. They don't have any direction. We need not have to mention the direction for these quantities to explain. For example, what is the time? For example, 2 seconds. How much is the length of the clock? For example, 2 meter clock. So all these few examples that I have given you, all these things, they don't meet the direction component. Those are called scalar quantities. Now next is vector quantities. What are vector quantities? There are many physical quantities. To tell those quantities, to define those quantities, we need to mention the direction. Now that is called vector quantity. For example, suppose force. Force is, all of you know that force is what? A pull or a push. Now when we apply force, we apply in a certain direction. So force is a vector quantity. So force, suppose I am applying some force on an object. So it has particular direction. So we will say that it is a vector quantity. For example, you are moving, you are running towards north. It is also a vector quantity. So whenever a physical quantity will have a direction, we will mention the direction along with the magnitude, that is along with the value. For example, I am running at a speed of 5 meters per second towards north. As soon as I have mentioned the direction, it is a vector quantity. Now, in this chapter, you will get two things. This is very important. You should read this and keep it in mind. Velocity and speed. So next we will see what is velocity and what is speed. First, we will see speed. All of you have heard about this word speed. What is speed? Now speed is nothing but, you have seen in maths also in small classes, speed is nothing but distance divided by time. So speed is equal to distance by time. Now this speed is something which don't need any direction. Suppose I am riding my scooter or scooty or a bike or my car at a speed of 15 kilometers per hour. Now this is having only magnitude. There is only magnitude, no direction. I have not mentioned in which direction. So this is called speed. Now with little bit of difference, it can be changed into velocity. So what is that? Same thing, if I mention the speed with direction, now we will have velocity. What is velocity? Now velocity is something where we will mention the speed, the magnitude of the speed will be given and direction will also be given. For example, a truck is moving with a speed of 15 km per hour towards north. Now it is moving towards north direction. So here I am writing the magnitude as well as I am writing the direction. So this is no more a scalar quantity, it is now a vector quantity. Okay? So next that we will see in our later on in this chapter that is given is displacement and distance. It is also a very interesting thing. You should always keep in mind because in physics you will need this every now and then. So next is distance and displacement. So let me first tell you about distance. What is distance? Suppose I have started my journey from a point A. This is a point A. I have started my journey from here and I am going along this path, a curved path, and I am coming here and I am taking a position B where my journey ends. Now from A I have started and my journey ends at B. So what will be my distance? My distance will be equal to the length of the path that I have traveled. So this whole length of the path that I have gone through is nothing but the distance. So distance will be, the distance will be total length of the path. So here I can say that the total length of path, total length of path covered by an object. This is nothing but distance. So this is what? Distance. So distance is nothing but the total length of the path covered by an object. Now next we will see displacement. What is displacement? Now there is a little bit difference. Not only little bit, there is much difference in that. Suppose I have started as the previous one. I am taking the same example. I have started my journey from A. I have gone through a curved path and I have ended my journey at B. Remember, just a few minutes back I have given this example. So what is the distance? The total path of this, total length of this path. Now, what is the displacement? From A to B, if I measure the perpendicular gap or the perpendicular distance, this perpendicular gap or the shortest distance is nothing but displacement. This is displacement. So from A to B, suppose it is 2 meter gap, though the object has traveled for say around 15 kilometer, but the starting and ending point, the gap that is there, that is called displacement. Now there can be a question. You may ask that, okay ma'am, suppose I have started my journey from one point. Say I have started my journey from the door of my class. After some time I have walked through whole school and I have come back to the same place from where I have started my journey. What will be the distance and what will be the displacement? Often this question is asked in the exam, so you should know. So if the initial, that means my starting point and my end point of the journey is same. So if A and B are the same point, that means from where I have started my journey, there only I have ended. In that case, my distance, it can be many meters or can be kilometers depending on how much path you have traveled. But displacement is going to be 0 because there is no gap between the starting and the final position. So my displacement is 0 but distance is not 0. Here one more thing you should remember, that distance is a scalar quantity. Before that I have told you the scalar and vector. So distance is a scalar quantity, whereas displacement is a vector quantity. Okay? So distance we will consider as a scalar quantity and displacement as vector. Now there is more to think that you should know. Speedometer and odometer. What are the uses of these two? Speedometer is a device we use to measure the speed of any vehicle. You will see the speedometer in bike, cars and different other things where it shows how much is the speed at that particular moment. You will see in bikes, scooters and all, the speedometer reading at what speed that particular thing is moving. So that is called speedometer. So speedometer, it measures speed. Odometer is a device which is used to measure distance. That means total distance, how much that vehicle has covered till now. That means suppose today I am going to see the odometer reading. It will show me total how much distance it has traveled from the time it has been started moving. That means from the time I bought that thing and till now how much total distance is covered. So odometer is used to measure, to show distance. Okay, I hope till this much it is clear to you. Hope that I will see you in the next class with more information. Till then, take care. Goodbye.